Alright, so today, continuing on with triangles and looking more at isosceles and right triangles today. Right, so first off, a few definitions. Base angles are going to be the two angles adjacent to the base of an isosceles triangle. If you remember, the base of an isosceles triangle is the side that is not congruent, right? You've got two sides that are congruent. The third side that's not congruent to those is the base of the isosceles triangle, so the angles on each side of that base basically are going to be your base angles. The vertex angle is going to be the angle opposite the base of an isosceles triangle. So if I got an isosceles triangle here, the base down here BC, the vertex angle would be angle A. And angle B and C would be the base angles. Theorem 4.6, the base angles theorem, says if two sides of a triangle are congruent, then the angles opposite them are congruent. And theorem 4.7, which is the converse of the base angles theorem, tells us if two angles of a triangle are congruent, then the sides opposite them are congruent. So either way, if I've got two congruent sides, then the angles opposite those are going to be congruent, or if I've got two congruent angles, the sides opposite those will be congruent. So basically, if you got two parts that are congruent, then you've got another two parts that are congruent, so to speak. And corollary theorem 4.6, if a triangle is equilateral, then it is equiangular. All right, so remember, equilateral is that all three sides are congruent. So if all three sides are congruent, then all three angles are congruent. And corollary to theorem 4.7, if triangle is equiangular, then it is equilateral. So basically what we get from this is if we've got two or more congruent angles, then we've got two or more congruent sides. Right? So we got three congruent angles, we got three congruent sides. Two congruent angles, we got two congruent sides. So forth and so on. All right, so then theorem 4.8 is the hypotenuse leg congruence theorem. It says if the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and a leg of a second right triangle, then the two triangles are congruent. So if I know that if it's a right triangle, then we just have to have two additional parts of information to know that they're congruent. So if the hypotenuse in one leg is congruent to the hypotenuse and the corresponding leg of the other triangle, then the two triangles will be congruent. Which technically you've got three parts that are congruent, because if they're right triangles, then the right angles are congruent as well. So even though it just says HL for hypotenuse leg, really you've got three parts. You've got an angle and two sides. So here we want to find the value of x and find the value of y in this figure right here. And so when we look at that figure, we've got 50 degrees right here, and we've got a couple of tick marks showing that sides are congruent to each other, right? So I focus on this triangle right here with the x and the 50 in it. It's got two congruent sides. So if we remember back to the base angles theorem, which says if we've got two congruent sides, then we've got two congruent, or the angles opposite those sides will be congruent as well. So that x angle and the angle in the other base angle there would be congruent angles, which means that we could call that one x also. And so to find the x, we know that all three angles in a triangle have to add up to 180, right? So this would be x plus 50 is going to equal to 180. Or 2x plus 50 equals 180. 50 from both sides. That gives us 2x equals 130. And then divide by 2. So our x value is going to be 65. And then to solve for the y, we look in the y triangle. It's got two congruent sides, so we know the two base angles are going to be congruent, which that y means that the other angle over here will be the same as y. But we don't have a number inside here. But since we've solved for x, we know that that angle right there is 65 degrees. And this angle here would be a linear pair with the angle right beside it, which would be this vertex angle. And so we know that those two have to add up to what? If they're a linear pair, they're going to add up to 180. So that angle is going to be 180 minus 65, 115. So now we can do the two y's together plus the 115 is going to equal the value of y, right? So y plus 115 is going to equal 180. Or 2y plus 115 equals 180 divided by, or subtract the 115. Y is going to equal 65. And then divide by 2. Y is going to be 32.5 degrees. Of course, another option we could have done to solve this one is knowing that this x right here was 65. If we remember the exterior angles theorem, which would say that the exterior angle is equal to the two non-adjacent angles added together, we could have just said 65 equals y plus y. But the other way works just fine too. All right, so the next one, actually a lot easier than the last two. Find x. So we got two congruent angles. So since we got two congruent angles, we know that the sides opposite those angles should be congruent as well. And so if one side is 5 centimeters, then the x in this one is also going to be 5 centimeters. Two congruent angles, we're going to have two congruent sides. Questions on any of those? All right, so next one, is there enough information to prove the triangles are congruent? Explain your answer. All right, so this first one, we got NOPM, which we notice these are right angles here, N and P, making triangle NMQ and triangle MPQ right triangles. They got one side congruent. Anything else that we could come up with that would be congruent? This diagonal right here, MQ, which is shared by both triangles. So that would be congruent to itself. And if we look at what we've got, then since this is a right triangle, NM and PQ are both legs, and MQ here will be a hypotenuse. So we got a hypotenuse marked congruent to a hypotenuse and two legs marked congruent to each other. So can we prove them congruent? Yes. I HL, hypotenuse leg. And these two triangles down here, RST and UVW. Got all the angles of this one are marked congruent to all the angles of this one. And if I look, one tick mark on all three sides of this triangle, two tick marks on all three sides of this triangle. So that's telling us that every side in this triangle is the same length, and every side in this triangle is the same length. But these are two tick marks, these are one tick mark, right? So that means that they're not the same length from triangle to triangle, just within the triangle. The sides are all the same length. So would we be able to prove those triangles congruent? See one shaking of the head. All right, so since we got all the angles marked congruent, and we don't have an angle congruence postulate or theorem, so we have to have a congruence between the sides between the two triangles. There has to be at least one. But since none of these sides are marked the same as these sides, then that means there's no congruence between the corresponding sides. So this one's going to be a no. Say there is no proof of congruence between corresponding sides. All right, and that, I believe, completes the notes. So that is 4.6.